Hi friends, now I would like to explain the concept of main memory in computer organization, generally called the subject as CO, computer organization. We know that the main memory or memory is an essential component of the computer to store both instructions and data. So the processor can access anything to process and to store the result again in the main memory. This main memory is basically divided into two components. One is the random access memory. The second one is the read only memory. Once again, I repeat the concept that is, so many people consider that the ROM is a secondary memory. It is a wrong. The ROM is also a main memory. Before I am going to into the concept, I will explain one architecture, especially about the ROM. The ROM consisting of only the necessary programs which are used to start the machine. These programs are known as bootstrap programs. These programs are directly functioning on the hardware of the system. They are used to start the processor and other components within the computer. Generally, as per my knowledge and expectation, for Windows operating system, there are four programs are necessary. One is the command.com, second one is the io.sys, the third one is the config.sys, the fourth one is the auto.exec.batch. This is the batch file. So the minimum programs which are used to start the computer are fabricated or stored within the read-only memory and supplied with the computer. So the name of this memory represents read only. That means we can only access these programs from this memory to start the computer, but we are unable to write anything into this memory. Hence, this is the basic thing. Suppose we would like to explain the interconnectivity structure as per our estimation knowledge with the computer. Let us consider this is the processor, right? The processor can access only the RAM, random access memory, actually. And let us consider this is the read only memory, which consisting of only the basic programs. And next, this one may be the secondary storage hard disk drive, which consisting of operating system and something. Let us consider whenever the processor, whenever we boot, that means we switch on the system, the necessary programs from ROM is loaded into the random access memory, and these are executed by the processor. Then the processor can identify where the operating system within the hard disk is stored by calculating the address, and with the help of that those programs it will access the operating system from the hard disk drive to RAM, and then it will be executed. Then only we are able to saw some display on screen or in on visual display unit or on monitor. This is the basic interconnection structure, how the processor, RAM, ROM, and secondary storage, hard disk are interconnected. Only these things are explained in point of view of the knowledge. This is not actually the memory organization concepts in computer organization. Now I enter into the actual concepts of the memory organization. So, and here I can explain these memory organization concepts as a two parts. One is, as usually we all know that the main memory is divided into the two concepts. One is the random access memory and another one is the read-only memory. In first part, I am going to be explain the chips and the functioning of RAM and ROM. And in the second part, I would like to explain about how these RAM and ROM are interconnected to the computer. So, just I can say that RAM, that is one kind of the chip fabrication. The full form is the random access memory. This is also known as the primary memory, and this is also known as the temporary memory, and this is also known as the volatile memory. Why? Because means whenever the power is switched off or whenever we simply shut down the system, the contents which are stored within this memory, that means this in the random access memory, are lost. Right? The either we switch off the system or the power is lost abruptly, the contents are lost. So for that reason, this is known as the temporary memory and volatile memory. The RAM is in a format like that. The RAM is like the set of locations, and each location is identified by a number known as the address. Suppose this location number is 101, 102, 103, 104, 105, and so on. This is 106. These are known as the addresses or address of each location. The general capacity of the each location, suppose I am going to be consider one location within the RAM is 8 bits, that is 1 byte. So why we are going to be call it as a RAM means, so to access any location, either it may be the first location or the middle location or the last location, the processor can take unique interval of the time t. That means to access the data or to store the data in the first location or in the middle location or within the last location, the processor can take the same amount of the time. This is known as these are the characteristics of the RAM. For the basic computer, we would like to interconnect a RAM whose capacity is 128 bytes. Right? This is 128 by 8 RAM we would like to interconnect it. That is the number of locations is 128 locations, and each location consisting of the 8 bit, that means 1 byte length. So there are 128 locations are there. Hence, to address or to identify each location within this RAM, we need 7-bit address. That means we know that 2 to the power of 7 equal to 128. Suppose let us consider this is the 0 location. The last one is the 127 location. Here I am going to be represent in decimal number. Actually, the first location consisting of 7 zeros and last location consisting of 7 ones. So hence we need the 7-bit address to identify any location in this RAM. Not only this one, this chip may also consisting of, here I am going to be write the entire structure of the RAM. That is, let us consider this is 128 by 8 RAM chip, and it is also considered as the length of the location is 8 bits, hence it consisting of 8 bit 8 bit to and fro. That means either to store the data or to send the data to out. 8-bit data bus or data lines. It also consisting of two control signals. One is CS1 chip select 1 and another one is CS2 bar. Why this bar? I will explain later in the second part. That is how these chips are interconnected. And one more signal is actually in the RAM, that is the read signal. Read means to access data from the RAM, and another signal is the write signal. Write means to store the data within the RAM. So this is the architecture of the RAM. I will show the diagram also in another. So please consider this is the RAM chip, that is the CS1, that is chip select 1, and another one is the CS2 bar, that means chip select 2, and another one is the actually read and write. So here I am also forget one thing, that is the one more thing is the 7-bit address. Here I am going to be consider the address lines to identify the RAM chip 7-bit address. Okay friends, okay, I hope, right, how these, how we are able to access the data from the RAM means, I am below I am given the one table and I draw the same thing. Please observe this one, please wait a minute. So how this RAM chip will work out? Just I am once again I draw the this RAM chip for easiness of your visualization. Right? This is the RAM chip 128 by 8 random access memory. This is CS1. This is CS2 bar. This is the read signal, and this is the write signal, and this is the 7-bit address, and this is the 8-bit data. So let us consider the truth table of this one is, so I am going to be represent here itself CS1 and CS2 bar, and one more, please observe here this diagram, right? And what is the function and state of the data, that is function and state of the data, right? I'm going to be right here, right? Function, what happened, this is okay. Suppose the CS1 is 0 0 and CS2 is 0, it will not going to be work anything. Suppose CS1 is 0 and CS2 is 0, sorry, 1, even it also not work anything. Suppose this is 1 and this is 0, now the read signal is enabled, the data stored within the RAM. Suppose this is 1 and this is 0 and write signal is enabled, right? The data, sorry, the data is extracted in read and the data is stored within the RAM. Again, this is 1 and this is 0. No function is happen. For your reference, I show the diagram also. Please observe carefully here. That is, I am going to put as CS1. I am going to be make it as a large one, right? At 0 0, nothing to be happen. That is the circuit, the RAM chip is not working. 0 1, right? This is also be 0 because CS1 is 0. This is also not working. 1 0 0 0, that is not working. 1 0, read signal is enabled, right? The data is read from the RAM. That is 1 0. Write signal is enabled. That is here. The write signal is enabled. Data is write into the RAM. 1 1. Nothing to be happen. For your understanding, once again I am going to be explain this one. That is, consider read and write signals, that is CS1, CS2 bar, RD, that means read, double R, write, and function. So this is 0 0, nothing to be happen. This is 0 1, again nothing to be happen. This is 1 0, that means this chip is enabled, and read equal to 1. Actually, the function is data read or extracted from RAM. Suppose 1 0 and the read is disabled and write is enabled. Data stored in RAM. That is again 1 1 CS1 and CS2 bar. Nothing to be happen. No function is performed. Okay, friends. I hope you can understand the functionality of the RAM. Thank you.